Now I want to do problem 533. I think you have 534, which will be similar. Mine says the dimensions of the jib crane are given if the crane has a mass of 800 kilograms, center mass G, and a maximum rated force at 15 kilonewtons. So that's what I'll put there. Determine the reaction at the bearings. The bearing A is a journal bearing, supports only a horizontal load, so there's my A, horizontal, whereas B is a thrust, which supports both. And so I've got X and Y, and I've put them both in the positive direction, and if I'm wrong, I'll get a negative number out. So here's my schematic. I've got a rectangle and a triangle. It doesn't quite, exactly the right shape, but it's not going to matter. I put my F here. I put my weight here. And I use my center axis is where I put my forces through. Notice I've got A going through the same place that F does. BX and BY here. So let's 800 kilograms mg. I get 7.8 kilonewtons. Well, on that one, it might do to show another point. I've got it set to show 1. Let's show 2 for that one. Yeah, so make 5 kilonewtons. And so what I'm going to do is I'm going to sum the forces. I'm going to sum the moments about B first, calling counterclockwise positive. So BX and BY, 0 moment arm. A would be clockwise, so it'll be minus, and its vertical distance is 2, so 2A. The weight next is, again, the distance between these two lines is 0.75. It would be counterclockwise. No, it would also be clockwise, so it's negative, weight times 0.75. And then my force over here would also be clockwise, so it's, and it's 3 between those two lines, the perpendicular distance between those two lines. So notice they're all negative, which is telling me A is going to have to be negative, because they can't all be negative and add to 0. Remember, they have to add to 0 in our situation. So I do that algebra to get A, and I get a minus 25.4. And then it's simply a matter of summing the forces in the X. There's only 2, A and BX. And of course, BX is minus whatever A was, so they add to 0. And then in Y, you got BY minus weight minus F. And that you get, so I get that. Now, if you look in the back of the book, he's got A and BX being both positive, and that would be if you drew them, but that's a little confusing. So, but they can't be the same sign. They can't point the same direction. So I think we're pretty clear here. I think the book's a little ambiguous. So anyway, I decided to check it since that was an issue. And so I took the moments about F. I thought about doing it about G, but I don't really have the vertical distances to G. I only have the horizontal. So I do it about F. A and F both can't cause a rotation, but BX and BY and the weight can. Let's see, what did I do first? I did the weight. So it's 3 minus 0.75 from between these two lines, and that would be counterclockwise, so it's positive. And then BY, the distance is 3. It's the same as F. It's it's opposite to the weight. The weight was clockwise. This one's going to be counterclockwise, so I got minus 3 times BY, right? Yep. And BX, its perpendicular distance is 2, if we assume they're on the same line, and that's going to be clockwise, so it's a negative. Or rather, I'm sorry. Do that again, about F. BX is going to be counterclockwise, so it's positive. And if you add those up, you're going to get 0. So it agrees with the numbers in the back, and in addition, I did a moment to check it. Again, the trick is getting that free body diagram right, and then your equations flow from it. Have any questions, shoot me an email.